Hello everyone and welcome to this video. Recently I got chance to participate in 5-day intensive generative AI course that is sponsored by Google in collaboration with Kaggle, where we got chance to explore the new models that were created as part of the Gemini 2.5 family. And there is a Capstone project where they allowed us to explore our ideas of our own and use all of the Google Gen AI models to actually solve a real world problem. Not to the extent of really solving it, but at least providing a pathway for how to solve it. So as part of that, this is my own take of uh, how we can use AI powered security analyst. I called it GenSec Analyst, and this project or the video now demonstrates the AI-powered agent that can automatically triage CVEs and also ingest a lot of threat intel documentations from government agencies or vendors and summarize it for the cybersecurity analysts. Now, to understand why this is the need of the hour, we need to first discuss about the problem that the cybersecurity analysts are facing as part of their vulnerability management. There are thousands of new vulnerabilities that will get published every week, and security teams are generally very overwhelmed because they had to either use their own set of scripts or code to triage these vulnerabilities and make sure that nothing is slipping through and making sure that they're only looking at vulnerabilities that are relevant to their tech stack. To demonstrate this as part of the NIST database, right? If we look at it, there are close to 275,894 matching records, and there are lots of vulnerabilities. Even if it is done via an automatic way of using some Python scripts and all, there is no good reporting format that can be used by the vulnerability management teams to generate reports in such a way that even business people will understand the context and prioritize the vulnerabilities. At the end of the day, the vulnerabilities should be explained in natural language for business people to understand, and executive summaries of these vulnerabilities are very crucial. Security teams face serious pain points because of this. There are thousands of CVEs that are getting released monthly. Most of them, or we can say many of them, might be irrelevant for a particular organization, and manual review or code-based review is still inefficient and error-prone, and the triaging is slow, and there is chance there will be missed 0 days as well. The manual prioritization lacks context because there are multitude of technical applications using different stacks, and emerging threats are often going unnoticed because either they were identified too late. We can see that there are lots of old CVEs that are still getting exploited by attackers, and the reporting formats are inconsistent. The reason for that being it depends on who is generating the report and the state in which they are present at the time of report generation. So to have that lack of uniformity will be a bigger issue for executives as they need to read this information very quickly and understand why a particular vulnerability needs to be fixed immediately instead of prioritizing a money-making feature. To help security analysts better do their CVE triaging and threat report generation, as part of the Capstone project, I built GenSec Analyst, and what it will be helping the security analysts do is it will avoid their information overload by taking the heavy prioritization and filtering tasks onto it, and also it will help them by fast faster triaging by making sure that CVE parsing, summarization, and scoring is done by the AI agent itself. And also it will make sure that there are no missed 0 days by giving proper cross references with real systems and monitoring and emerging threats as well. And it will make sure reports are in good condition by making sure that they are structured and consistent. Now, as part of this GenSec AI project, what we did was we went ahead and used the NVD API for getting the vulnerability results, and also I provided capability to run this natural language searches on top of the GenSec CV data stores. And also there is capability to add technical stacks, and it can do advisory and threat intel summarization as well, and produce machine readable format for vulnerabilities, and make sure that it allows searching for CVEs and patch status of vulnerabilities by function calling. So in terms of the Gen AI capabilities used, it is a retrieval augmented generation based system, and there is vector database available, and it can generate JSON, structured JSON output, few short prompting, document understanding, and function calling. Now let us see the GenSec AI in action. So the first crucial step that is needed is we need to have CVE information available to us to be able to add natural language processing on top of it. So for that, we are going to use fetching the raw CVEs from NIST NVD API, for which we already have an API key, and we can make requests from Kaggle out to NVD NIST API, and we are going to make sure that it is done in such a way that we are not actually hammering the NIST API server. We're just going to do it based on throttling. So once we click on this cell in Kaggle, what it will do is it will just go and it will fetch the CVEs from past one day. After that, the next important step is we can't do much with raw CVEs. So what we need to do is we need to parse the CVEs into a text format, including their metadata and all the relevant fields that will help us in doing the semantic search. So for this is the second step. Now we are going to parse the CVEs, which is good. Once we parse the CVEs, the third crucial step would be to store them in the Chroma database, which is a vector database, including their distances and everything. So now we retrieved 69 CVEs and we stored them in Chroma database. And what it will help us do is it will make sure that the CVEs are actually stored in high dimensional vector format so that Gemini can actually properly search for it. The crux of the whole of Gen AI Kaggle notebook lies in this run RAG system. Let us run it and see the options that are available for us. So with the CVEs being fetched from NVD NIST API and parsed into usable text and then stored in the vector database, Chroma vector database, now we can start doing natural language query searches. Let us enter option 1 here. Now the question that the model is asking is, can you enter the search query? let us type something that will never hit any of the CVEs to prove that natural language search or semantic search is working. Important vulnerabilities to review. So NIST will never have something like this working in their search. So let us type enter. Now our model is saying it found 5 relevant vulnerability results, and we can see that here's a rundown. It is saying something about HP touchpoint analytics service vulnerability, and one about PHP Gurukul SQL injection and CMS SQL injection, and it is explaining about some of the vulnerabilities that are important. But we can see this is just general vulnerability, natural language search. It is not related to any of the tech stack or anything like that. And now the model is asking, would you like to see the source of CVE details? Let us say yes for it. Now it is actually showing all the CVE IDs and all of the information that it got from NIST, and some details about whether patches are available or not. Source 1, source 2, or it gave source for all of the 5. Now let us look into the second option that we have as available, that is tech-aware vulnerability search based on your tech stack. So it is saying based on the tech stack that we have, it will do vulnerability search. But before that, we just need to see what is this tech stack that we have. Let us type the choice 4 to this. And what it is doing is it is allowing us to view the current tech stack. First, let us look at this option. And I prepared a sample tech stack if the user, so that it will act as a baseline for the user. So if we see, we have web servers of Apache, Nginx, databases, operating system, programming languages, and frameworks. Okay, let us go back to the main menu by typing 4 here. And let us do a tech-aware search. Let us answer concisely based on my tech stack. What are the important vulnerabilities to review? Let us see what it replies. So now what the model is doing is it is first going and looking if it has LRU cache results. That means if a similar query is executed previously, it will retrieve from cache. Otherwise, it will try to retrieve by executing the pipeline of model to Chroma vector database, then answering on top of that. So if you see, it's saying we have an XJS authorization bypass. Be careful about that. And it is saying some SSRF and redirects and AppSmith and Next.js. And the same way, it will show the sources of these vulnerabilities as well. So that's all good. Now let us try to go back to the tech stack again, and let us try to add a technology. Now if I type in 2, it is asking what is the technology name you want to add. Let me say Oracle. And which category does this belong to? Databases. Now what it is doing is it added Oracle to the databases, and now it is starting update of its vector database so that it can fetch all the Oracle related issues as well if there are something that raised in the last day. And what it is saying is it does the update. Now let us go back to the main menu and ask, are there they have to type 2 for tech aware search. Are there any Oracle database issues? Now what it will do is it will again start doing the search based on the tech stack, and it is saying there are some Java VM issues, and there are some Oracle net issues. It started picking up relevant issues that are closer to what we have asked, RDBMS and other stuff. So what it is saying, it is adding a bit more context. It is crucial to monitor like the security alerts page. Let us say we don't want to see the source of this CVEs. That's all good. Now let us go back to managing the tech stack. Let us view the tech stack. Now we have databases as Oracle. Now what we let us do is let us remove Oracle from the database. Let us type 3 here so that we can remove the Oracle database. Oracle. Then it is saying what is the category. It is databases. Now as part of a removal as well, it will again do the update of database, because it needs to now only fetch things relevant. So it will try to remove the Oracle database. So what will happen is it will let us know once the update is done. Now if we go back to the main menu, and if we do tech aware search and just say, just wanted to know, are there any Apache server issues? So now it will go and search, saying that there are some Apache issues like off-base, traffic server, and other stuff. If we just say N for that, it will go back to the main menu. So now so far we have seen natural language search, tech aware search, managing the technology stack. Let's look into the semantic search method. This is the one that is powering the natural language search that we are seeing. And this is the same method that is used for both tech aware search as well as the regular CVE search. So the first statement that we can see is it will try to see if the query is matching, and it can retrieve cached results for that query. So it's a simple LRU cache. If we go up in the Kaggle notebook, we can see we have self-contained methods for maintaining the cache. If cached results are present, those will be returned instead of like wasting the throughput by hitting the vector database and making Gemini answer the question. Now, first we will normalize the query. The reason for normalizing is to make sure that semantic search works without any hiccups. And now, as this is not document creation mode, it is a query mode, we will be setting this to false. And now we will be running the query, the normalized query, and we will try to get the top 5 results. And we want to include documents, metadata, and distances as well. Why distances are needed is to make sure that the semantic query is running based on the threshold. That means if it does not match the threshold of at least 0.85, then those results will be discarded. So this loop is doing that. And finally, before returning the results, it will set it to query cache, because if we type in the same set of query, we just return that without actually hitting the full pipeline again. Now, in terms of understanding how the semantic search is working, right? Let us go to the bigger method that we have, which is related to that run RAG system. Now, if we go back to the bigger method and then see, so for natural language search, which is choice 1, we'll be reading the query, and we will be going and doing a semantic search with 5 results being retrieved and 0.85 being threshold. And now, once we have the result documents, what we will be doing is we will process and display the results. So what is this process and display results? We will be actually going through each document and preparing a prompt, whether it is tech-aware one or a regular one. We will just prepare the prompt and add all the passages here, and we will be relying on Gemini to Flash to actually provide a concise response based on the query of the user. And that is how we are actually powering the natural language search on regular CVEs as well as the tech-aware search. Now to show a bit more on the tech stack management, right? So we will be using the tech profile that is set as default. And if the choice is 1, we just go ahead and display the tech stack. If it is 2, we'll make sure that we are adding it to the tech profile and we are fetching relevant CVEs again based on the updated tech profile. And we pass them, store them in the Chroma database again. So there is a separate collection for CVEs of tech-aware search. This is just made to keep it separate and make the search results much faster by not mixing the regular CVEs with the targeted CVEs. The choice is 3. Then we will remove the product from there and then from the tech profile, and then we'll again update the CVEs and add them to the targeted collection. So what's happening as part of the semantic search and tech stack is what is actually there is a bit of heavy lifting that is happening for getting the information, processing it in such a way that it can be stored in vector database so that Gemini to Flash can actually work on top of this content to provide good answers to the user's queries. Now let us look at the third option, that is having a structured JSON output. This will be good for SAM tools to be integrated into the GenSec Analyst, AI Analyst. So if we type in 3 and give it a natural language query, still what it will do is it will try to go ahead and retrieve all the CVs that are relevant to this query and start displaying them in the JSON format instead of a natural language. So what is powering this whole behavior is the ability for the Gen AI model to be able to process all the documents and generate a structured output. If we go to this method and have a look, so what it is saying is you are a vulnerability analysis system. So based on the information, actually provide these as a JSON output format, which is passed as a JSON for it. We can have a look at it. It's passed as JSON. And now what happens is it will go through all the semantic search results that it got out of the query and instructs Gemini to Flash to actually respond in application/JSON format. That way, the response that we are seeing here is actually JSON instead of it being a natural language text. So let us look into the document-based summarization or search functionality or capability of the Gen AI model and the GenSec AI Analyst. Now, if we type in the option 5, what it will ask us to do is it will ask us to select from the following. Let us do a natural language query. This will search across all the documents that we have. And what do we mean by these documents? So if we go and see in Kaggle again, right? So there is a big set of 6 documents. Say for example, trends for businesses and organizations from Cyber Threat Report of Australia, critical infrastructure, individuals, CrowdStrike report, Commonwealth Cybersecurity Posture, ASD Cyber Threat Report. So all of these are actually ingested, and then the model, Gemini 2 model, can actually do searches on top of it. So if we go ahead and then see the option in here, right, we are doing a choice 1 here, and what it is saying is it is just going and saying answer question method, which is actually generate an answer to the question using the knowledge base. So knowledge base is all the files that we have ingested in using the Kaggle datasets and the query of the user. Now, if we go in and say, let us say 6 documents, it's very hard for us to read. Now we can actually ask it a question saying that I want to do a natural language query. Top 3 vulnerabilities across all the 6 PDFs, which might be more than 200 pages. Now it goes and then searches for all of the PDFs and says top 3 threats are lack of multi-factor authentication, outdated software, and weak passwords. Now, if you want to get a concise threat analysis, we can type in 2 and say it will automatically go ahead and then do the search across all the documents, and it just gives concise list of all the issues that are there: threat categorization, severity assessment, and prioritization. So how does this concise threat report work again? If we go back to the code, so it's for choice through, we'll do analyze threats. What it will be doing is it's giving a prompt saying it is you are a cybersecurity expert. Prepare a report that covers all this, including the threat info from the documents, and do it in a concise manner. See, generating something like this would take at least 2 days or 1 day, 1.5 day for vulnerability management teams, because they had to read through all of these reports or 6 PDFs and then start generating a report. But GenSec Analyst, with the help of Gemini 2.0 and the capabilities of Gen AI, it's able to do it within minutes. Now we can do document specific search as well. It will show all the available documents. Let's say I want to use document number 6. So what it's saying, what are all the, okay, it selected the 6th document. It is asking, okay, what are top 3 issues mentioned in this document? What it will do is it will go and then start searching for top 3 issues in ASD Cyber Threat Report 2024. Even this kind of activity will be taking a lot of time. So they're saying there are states, sponsored cyber activity, cybercrime, critical infrastructure vulnerabilities. Now, this is how we can do document summarization and document searches using Gemini and its Gen AI capabilities, and make sure our GenSec Analyst is in an advanced state and helping the vulnerability teams. Now, going into the few short prompting. So this is actually giving a couple of examples to GenSec AI and actually asking it questions. Any concerning CVEs to look into? So what this one will actually be doing is it's saying some of the CVEs. It's saying there is some macro video technologies, attack vector is network, and it's talking about some unknown severity vulnerability, and there are some things that it is mentioning. So how it is doing, well, let us go and look into the technology behind this few shot prompting. So it's actually getting done using choice number 6. So we can actually create a few shot prompt for Gemini. What it is saying is you are a vulnerability information expert. Answer questions about security vulnerabilities based on information, provided information. And it has a couple of examples. So these are a few short examples. So let us say if we ask question about impact of CVE like this, or tell me about Windows vulnerabilities, it will just use this kind of responses and start creating its own responses. So if we see our question falls into the second category, so it's trying to respond in such a way that it's just trying to use those examples and prepare its own consistent way of responding. Now on to the final capability of the GenSec AI Analyst, that is function calling. So what it will do is it will provide Gemini model ability to actually use predefined functions to reach for other sources of information that it might not be privy to as part of the data setup. So now we don't know whether this CVE exists as part of the current pre-processed CVEs that we got from NIST API when we are running the Kaggle notebook. But we can still go ahead and ask this question. Now what the model will do is it will try to use the functions that it got provided with, call those, and start preparing this information. So patch is likely available is false for it. Now if we go and see what is this function calling, so it's, let's go and see process with the function calling. So it got some function descriptions. So we just have to see what is this setting up function calling. Now it's saying the model can access two. One is check patch status and get CVE details. Now using those two function declarations, Gemini model will actually be generating a response. What it is saying, what it is trying to do here is it will look for candidates that it can execute based on the query that is provided, and finally return the response that we are expecting from it. If we see now, it's trying to say patch is likely available as false because it can't find anything in NIST. So what is happening behind the scenes is it is actually making a call to NIST to get the patch information and generating this JSON output, which can be integrated with SIEM tools or potentially Jira and others. Finally, we are done with all the options. We can click on 8 and it closes the while loop that is running constantly, listening for user inputs. And with this, we have demonstrated all the functionality and discussed the technology behind it and how GenAI helps. Now let us discuss about the limitations and the future direction that we can take using these GenAI models. Now let us look at some of the limitations and learnings that we have from these GenAI models. So GenSec Analyst that we have seen, it definitely can push the boundaries, but it still has some limitations where there is dependency on getting this fresh data from upstream CVE feeds because it can only work with what it has, and if the information is not available for it, then the whole of stale data will be used for generating answers to the queries. It is still prone to hallucinations, but we are mitigating it as part of this experiment or project by using structured responses and verifiable sources. And now what it will do is if it doesn't provide a proper CVE number that we can search against the open source tools that we have, then we know that it is hallucinating. Now, in terms of tech stack sensitivity, so relevance ranking is only as good as the maintenance of the system. So if a system doesn't even have a CMDB, it is very hard for GenSec AI to give relevant results for it. At that moment in time, the teams would have to rely on searching for the regular NLP-based CVE search. What's next as part of this Capstone project and the total future of autonomous security analysts? So this is a glimpse of what is possible when we use good AI models like Gemini 2.0 or 2.5 to actually integrate it with the cybersecurity workflows. So now we can have a good future where agents that automatically open Jira tickets for critical vulnerabilities, and they can actually message on Slack or MS Teams with or Google Chat for that matter, and do a real-time collaboration with human analysts and multi-agent setups that actually looks across the infrastructure and agents that can do real-time threat blocking by looking at advisories and reacting in real time. So this is just the beginning of the prototype of always on, always alert security partner that all of the teams can have. Some final thoughts on the whole state of cybersecurity and agentic AI or Gen AI. Cybersecurity, as we know, is always a tug of war between defense teams as well as the offense cyber criminals or attackers. So any advantage actually we can gain against this ever expanding threat landscape should always be considered and implemented. And with GenSec Analyst that relies on the capabilities of Gemini, we will be giving defenders a very good head start by helping them get on top of all of these advisories, multitude of documents that they need to read for these threat analysis reports, and the CVEs, thousands of CVEs that they need to parse through. So what we can do is by combining this retrieval, reasoning, and reporting into a single intelligent agent, we are actually reimagining the future of vulnerability management. And what we are doing is inherently reducing the imbalance that exists between the offensive operations and defensive operations by leveling the field, by giving an invaluable automatic and intelligently thinking partner to defensive teams that are doing the vulnerability management. A very big thank you to Google and Kaggle for allowing me the opportunity to learn about these advanced Gen AI models and their capabilities, and also putting it into practice by creating a capstone project. And thanks a lot for giving us the platform and the environment to be able to go through this great experience of actually learning about these advanced large language models.